Under the analytics page, we have our torque projection plot on the right-hand side. So what we do for these plots is our engineering team will model up every well before the job starts and add in these projections from TAD Pro into BoreSite. So you'll see these dotted lines here ranging from green to yellow to orange and red. Each one of these lines signifies a torque projection at a different friction factor. Most of the times we will plot these lines ranging from a 0.15 friction factor all the way up to a 0.40 friction factor. The reason we do this is we want to give our end users a wide range to view their torque data and their projections so they get an idea for how we're following along. In this case, a 0.15 friction factor denotes low friction, and we should expect to see lower torque at this projection. On the other side, we have a 0.40 friction factor, which is this red line on the right, which would signify really high friction, which gives us a higher torque projection. This white line you see is the applied rotary torque that's taken from their sensor data plotted on top of these charts. What this does for us and our users is gives us the ability to be able to see how our torque is trending throughout the well. Recently, we've added the addition of chemical injection data into this torque and drag plot. If you go to the three dots in the top left, you can choose between a pipe-on-pipe total and FR total. So in this case, we want to see the relationship between how pipe-on-pipe is affecting our rotary torque. We have the option to change the color intensity for this chart. So if it goes down to 0, you really can't see when we started pumping pipe-on-pipe. However, when we bump up that color intensity, very clearly see the gradient of whenever we started pumping pipe-on-pipe. The end goal here is to start to understand relationships better between the pipe-on-pipe being pumped and the effects it has on the rotary torque. In this case, you can see on this well we started rotating around 8,000 feet and didn't pump chemicals until right around 15,000 feet. And during this time, the torque was following a 0.34 friction factor. After the chemicals started being pumped right around 15,000 feet, you can see it denoted by that white line turning green, and you can see how the torque started trending towards a 0.28 friction factor. So again, this is just another way to see the positive impacts of the chemical program. Another feature in the torque and drag model is we have this heat map. Using this heat map, instead of just looking at average values, we can see a range of values for every given depth that our operator is tagging up. So what this does is just gives us a little bit better of a analysis. If torque's going all over the place, this will help us see the mins, maxes, and averages. We also have the ability to select drilling, washdown, and all on this chart. The primary differences is based off of our operator tags. Whenever our operators are on a plug, we can collect the drilling data and see how the torque is affected this way. The reason we made this differentiation is because certain operators have a preference on washing down at a certain RPM and drilling at a different RPM. By breaking it out, it gives our end users the ability to see how torque is trending for both cases. If users would like to download the data, they can click this download CSV button, and what this will do is convert this torque and drag model into CSV data. Once converted to CSV, we can see the data broken up by depth in the A column, and then we've got the applied rotary torque and subsequent friction factors also plotted out here. If you'd like to better view the torque and drag model, you can also make this full screen using the button in the top right. On here, this will just bring the torque and drag model right to the center and magnify everything on it. If you'd like to return to the analytics page, you'd simply go to the button in the top right to click out of it.